Thanks for taking the time to tune into the video. If you would like to reread the question, go ahead and just pause the video and do so now. In part A of this question, we are asked what is the mass in kilograms of one molecule of water? We've gone ahead and have drawn that molecule of water. In the center is an oxygen atom, and then flanking that oxygen atom are two hydrogen atoms. And the question states the mass of those atoms, but it gives us the mass of those atoms in this rather peculiar unit, this little u right here. That little u stands for an atomic mass unit. So if this question wanted the mass of water in atomic mass units, this would have been pretty easy because we could just add these numbers together. So the 16 atomic mass units plus 1 plus another one, that would of course give us 18 atomic mass units for the mass of a water molecule. But again, the question wants this mass in kilograms rather than in atomic mass units. So let's go down here and learn of a conversion factor. We can see here that one atomic mass unit is equivalent to this very tiny number of kilograms. We're going to use this as a conversion factor to change our mass from atomic mass units into kilograms. So here's how we do it. We take our mass in atomic mass units, and we're going to always multiply by any conversion factor. When you set up your conversion factors, you usually want to set them up as a fraction like this. And then the question is how to set it up. And it works as follows. You have your atomic mass units as your starting unit. And what you want to do is take that starting unit and you want to place it in the denominator of your conversion factor. So if atomic mass units is what you're starting with, you're going to put atomic mass units in the denominator of your conversion factor. And the reason for that is because they're going to therefore algebraically cancel. So this atomic mass unit will end up canceling with this atomic mass unit because you're essentially dividing them. And when you divide units, you get 1 and they cancel. And so now we look at the conversion factor right here, and we can see that one atomic mass unit, we'll put a 1 here, is equivalent to this, again, very tiny number of kilograms. We probably don't have to write down every digit. Why don't we just do 1.66 times 10 to the negative 27, and then this is kilograms. So the atomic mass units will cancel out, as noted earlier, and that's going to leave us with an answer in terms of kilograms. So now all you do would be to pick up your calculator and multiply 18 by this very tiny number over 1. And when you do that, you should get approximately, well, it looks like about 3.0 times 10 to the power of negative 26. And that would be in kilograms. That's the mass of a single water molecule in kilograms. So that completes part A. We come back up and look at part B. And part B asks us how many molecules of water are in the world's oceans, which have an estimated total mass of 1.4 times 10 to the 21 kilograms. So that's a huge mass, but of course that's taking into account all of the water in the world's oceans. What we're going to do is start out with that given quantity. When doing conversions, it's very effective to start out with the given quantity in that particular question. So here, this is our given quantity. We're going to write that down as 1.4 times 10 to the 21, and that's going to be in kilograms. Now, we're trying to convert this into water molecules, so keep that in mind. Let's revisit this notion of conversion factors. Again, when you multiply by a conversion factor, you want to make sure that the unit you're starting with is placed in the denominator of your conversion factor. So we're definitely going to want to put kilograms in the bottom here. And somehow we have to get this into molecules. Well, that comes from our result from part A. In part A, we did learn that one molecule of water had a mass that we had determined in part A. That was the 3.0 times 10 to the minus 26 kilograms. So that's how we can convert from kilograms into molecules of water. We can go ahead and cross off the kilograms, and that's going to leave us with molecules of water. So you would pick up your calculator, you would take 1.4 times 10 to the 21 and multiply it by 1 over 3 times 10 to the minus 26. When you do that, you should get an answer of approximately, let's see, it's going to be around 5.0 time, or 4.7 if you want to get a little fancy, but basically 5 times 10 to the power of 46. And that's going to be in molecules of water, a huge number of water molecules. But again, that's because we're talking about the number of molecules of water in all of the world's oceans. That would be the correct answer to part B.